Hi, I'm Steve Cook with the Michigan Department of Transportation, and I am the Engineer of Operation and Maintenance. And we're here to do a demonstration of the unmanned aerial systems that we're currently doing a research project with and partnering with the Michigan Technological University. I am the project manager for the project, and Rick Dobson and Colin Brooks will be doing the demonstration, and they are the principal investigators for Michigan Tech. Thank you.
Hi, my name is Rick Dobson. I'm an assistant research scientist at Michigan Tech Research Institute, and along with Colin Brooks, I'm a co-PI on the MDOT UAV Phase 2 project for MDOT. And my main roles on the project are I'm the primary UAV operator, and I also assist with integrating sensors and different payloads and data collections for the UAVs. So I have a couple of UAVs out here to show you. The first one here is a Bergen hexacopter. It's built by a company called Bergen RC, based right out by Kalamazoo, Michigan. It costs about $5,400. It'll get you about 15 to 20 minutes of flight time, depending on weather conditions and the payload you put on it. And we like to use this UAV for a lot of our applications, mainly because we can put all sorts of different kinds of payloads on it. It has a 2-axis gimbal, so it can compensate for the roll and pitch movements of the hexacopter itself. The only thing you'll have issues with if it's buffeting quite a bit in the wind, as far as collecting good data. Right now I have a Nikon D800 camera mounted to there. It's a 36.3 megapixel camera, and the advantage with this camera is, with a 50mm prime lens on it, from 100 feet away you're getting 1 centimeter resolution imagery. So at our typical flying altitude of about 100 feet above a bridge deck or structure, you're getting incredibly high resolution imagery. And that could be stitched together, and you can make 3D models to do further assessment, which I'll show later in my presentation. So before I take off, I was just, for everyone, I was just asked to speak a little bit about safety features of the Bergen Hex and safety in general with flying these, and what it takes to become a commercial operator, or even an operator through the state. So as of August 29th, the FAA released Part 107 rules for UAVs. And what Part 107 allows for is, previously you needed a pilot's license to operate these under the old COA Section 333 exemption. Part 107 means you don't need a pilot's license to operate, but you do need to pass an initial aeronautical knowledge test through the FAA. So this test will cover being able to read aeronautical charts, airspace classification, how to determine weather, good operating conditions. So everything you need to know to operate safely within a national airspace. Once you pass that test, you submit it through the FAA website, and you'll get your remote operator's certificate to commercially operate these. And another comparison, the old COA Section 333 exemption, you had to notify the FAA 30 days in advance of flying. Where you're going to fly, your operating parameters, how high, how long, and what device you're going to use. And your device also had to have an N number, which normal aircraft have to have. Your device had to have an airworthiness certificate, which normal aircraft needed. But under the new rules, none of that is needed. You can go out and fly wherever, as long as you are not within restricted airspace of airports, and as long as you're not impacting normal aircraft operations. So some safety features that the Bergen Hex has on it: if you take it off and you were to lose connection with the controller, it'll automatically fly back and return home and land where it took off from. Now you have to be careful, because its home point is wherever it first obtains GPS lock when you turn it on. So if you turn it on and then move it over there, it'll come back to this spot. It doesn't have any sense and avoid on it. You know, sense and avoid is myself and a designated spotter that I have to watch out for low-flying aircraft, moving vehicles, or anyone walking into our collection area. And there's a few other things that we do to make sure that we avoid impacting the public or anything else, and that is we always try to fly with an offset. We can't fly over any non-participating people in our collect. So anyone walking down the sidewalk, we can't fly over, and we can't fly over moving vehicles. So what we can do is we can fly at an offset. So I can fly at about 100 feet in the air and about 80 to 100 feet to the side of them, and I can still collect the roadway underneath. So if there's traffic on a bridge, I can fly offset of the bridge as long as I'm not flying over traffic itself. And as long as I get enough pictures taken, I can actually capture the entire bridge deck underneath and merge them together and remove all the cars from it. So I have an image of the bridge. And by doing that, you don't have to shut down traffic. You don't need inspectors out there getting in the way of traffic that can possibly be hurt. And everything is done remotely and off to the side away from moving vehicles.
So you're keeping the operator out of harm's way of traffic.
Yep.
You're not setting up a work zone, so you're reducing the whole user delay and all those kind of things. Yep. And the efficiency of collecting the data is far faster and far more accurate than what we'd normally do, correct? Yeah,
so what Steve was saying is that since you don't have to set up work zones and you don't have anyone actually going in the way of traffic, it's a lot safer for the operator, it's a lot safer for motorists and inspectors. And the data that you're able to get with this, with either the Nikon D800 or a thermal camera, is a lot higher resolution and has a higher quality to it, because you're no longer using subjective data. You know, you have an inspector going out there looking at it like, oh, that spall is about 6 inches wide, 3 inches deep. You know, you can actually collect high resolution imagery and with centimeter accuracy get down and figure out the exact size of each of the spalls and classify them for your NBS. So any more? All right. So I've already had it set up. This thing, normally the arms are folded so you can place it in a vehicle. So I took out the arms, I put the camera on it and the batteries, and I had to get GPS locked. So the purple flashing light right there means it's in GPS mode. So as it's up in the air, if I take my hands off the controls, it'll just sit there and hover. It'll hold its position regardless of what the wind is doing. So as I said, if I take my hands off the controls, it'll just sit there. The GPS is accurate to keep it within about a 1 meter box. And with the camera on a gimbal, I can adjust with looking straight down at nadir or off to any angle in between. And with this setup, and it's got a little bit of a breeze it's fighting right now, but I should be able to get about 15 minutes of flight time with it.
How far do you got to stay away from the power lines?
This is about as close as I want to get to the power lines. In case something happens, I want to have enough room to be able to react and get out of the way.
Is there any pre-planning with towers or airports before you
Yeah.
fly?
So as part of being able to obtain a remote operator certificate from the FAA, Steve was just mentioning if there's any planning that goes into before you fly. You have to be knowledgeable of the airspace. So you have to be able to look at aeronautical charts to make sure you're not in restricted airspace. So restricted airspace is usually found around airports with control towers, and those usually have heavier amounts of air traffic. You also have to be familiar with normal aircraft patterns at non-controlled airports, because under the new rules, instead of just being at least 5 miles away from any airport, you can actually fly closer to 5 miles to an airport without a control tower. But you have to be familiar with the aircraft patterns, because they have a certain procedure they follow with taking off and landing and following a pattern around the airport. So you have to stay out of those areas, because if you do impact air traffic, if a plane has to avoid you, you have caused a problem and you are in violation with the FAA. And they could fine you with careless and reckless, and that's at a minimum of a $10,000 fine per infraction.
What's the maximum height you can fly these, and what's the ceiling below the cloud?
So the hexacopter itself can fly several thousand feet in the air, but with the FAA rules, you're restricted to 400 feet max. You can deviate from that. If you are inspecting a building or a smokestack or any other structure, you can go, if you're within a 400-foot radius of that structure, you can fly to 400 feet above that structure. So if the structure is 100 feet high, you can, if you're within a 400-foot radius of that structure overhead, you can fly to 500 feet above the ground level. But if you get outside of that, you're only able to go to 400 feet. And the main reason for that is your normal air traffic will start with your basic Cessnas and everything. That'll start at about 500 feet. So that gives you a little bit of separation and keeps you out of that airspace.
And below the ceiling is what? The cloud? Is it 500
Oh yeah,
feet?
so you also can't fly in clouds because this is visual line of sight only. You have to be able to see it. So you have to stay at least 400 feet below a cloud and at least 2,000 feet laterally from a cloud. So if you're flying somewhere a little bit mountainous, or if you're in a UP, for instance, and you have low-lying clouds, you have to be at least 2,000 feet away from that cloud. And that's so you can see any aircraft that may be flying through that cloud base, and they can see you. So you can do that sense and avoid manually. So normally I have an FPV hooked up to this system, a first-person viewer. So there's a separate camera that I'll mount next to the Nikon D800. It has roughly the same field of view as that camera with that lens combination. And that'll send a video link signal to the monitor, and I can see exactly what the camera is seeing. It'll give me a readout of battery voltage, my altitude, and a few other things that are necessary for a collect. I don't have that today because the monitor actually died on me and I haven't replaced it yet. But under normal operating conditions, we use that to get more situational awareness of the collect, and to make sure that we're collecting what we need to. Because otherwise it's very difficult to see, if it's 800 feet away from me and 100 feet up in the air, it's really difficult to see if you're actually over the bridge or you're collecting the data you want. And right now the camera has a 64 gig SD card in there, which I can take about 2,500 photos. And if I were actually to process take all the 2,500 photos and process it, I'll have a extremely large point cloud on the order of at least 50 million points. And of course, your resolution on that point cloud would be less than a centimeter. So the question was about noise, whether it's a quiet one or loud compared to others, and whether we've gotten any complaints. No complaints, and as far as whether it's quiet or loud, I've definitely heard some that are quieter, but they have a different setup as far as the props. Because you could have different prop configurations. Our other one over here that I'll fly in a minute, it's a little quadcopter. So that's going to sound different than the hexacopter. There is also octocopters, which will have 8 arms and 8 blades, and there's also a quad 8 configuration, which we're purchasing for our UAV Phase 2 project with MDOT. So it's 4 arms with 2 engines on each arm, one on top and one on the bottom. And it gives you a heavier lift capability and still maintains a a small frame that you can easily transport.
At the same price?
Just a little bit more expensive. I think it's maybe $500–600 more expensive.
Oh, okay.
What was the price? I don't think you mentioned.
That was $5,400.
Yeah, this one is $5,400 and the other one's about $6,000. So you can purchase these with waypoint capability. This one right here, it does, but it's now 4 years old, and the waypoint capability isn't as accurate as we would like it. So we normally don't fly it with the waypoints. We normally manually fly it and use the FPV to make sure we're collecting the data we need. But newer versions of these, and I expect our Quad 8 will have full waypoint capability where you can do mission planning on a tablet. You know, you can specify the altitude, the speed you want to fly between points, and all sorts of other mission parameters, and just touch go and it flies its mission. And we have a DJI Phantom 3, and that'll do the same thing with mission planning. And the nice thing with that is all you have to do is press the return home button, and you can take full control over the quadcopter. So next I'm going to set up and get our quadcopter going. So this is a Mariner splash drone. This one is also another 4-year-old system. But the advantage to this system is it's a waterproof system. It can actually take off and land in water. And it will mount a GoPro to it, which I don't have the mount for at the moment. But it's basically just a suction cup mount that goes on the top or the bottom. And you can put 2 GoPros on there, one on the top and the bottom. And you can actually do bridge inspections with these over water. So we've actually landed it on the water and moved it underneath the bridge, collecting imagery underneath the bridge and underwater simultaneously, and then launched it from the other side. And it also gives you, if you don't want to land it on water, it gives you the capability to operate in a wider range of weather conditions. Our Bergen hexacopter here, all the electronics are exposed, so if it were to start raining, I have my amazing interns over here, Jeremiah and Danielle, and my colleague David Bannock over there. They will move into action and quickly swoop up the hexacopter so it doesn't get wet. So give me just a minute, I'll turn this one off and I'll get this one ready to go.
Yes, so a little bit about where we're at as far as MDOT and the use of these on our roadways. Recently we sent out a letter to all our contractors and all our partners that do construction for us, our consultants, our local agencies, to restrict the use of UAVs in MDOT right-of-way. So any road going over that's a local or anywhere in our right-of-way space, there's a moratorium right now on the use of these. And the reason for that is because we've had a lot of folks that have come to us asking questions about using these for things like construction, monitoring construction projects. So what we try to do is just limit the use of these for now. And it's going to give us the winter with this research project to be able to create a guidance document. And some of that guidance document information will roll into a procedure for us to use next construction season as a policy and procedure to be able to control the use of these in our right-of-way. There's one thing about is the right-of-way. When we say right-of-way, we don't control the airspace. So technically anybody could fly in the airspace. We only control the contractual mechanism between us and our partners that are out there working for us. So that's the piece that many folks don't understand. We don't control the airspace, just the right-of-way in terms of contractual uses and how we partner with our contractors and our consultants. So that's the state of the practice right now. So we're hoping next year we'll be using these on a limited basis depending on the use case.
So while this gets GPS locked, as I was saying earlier, it's waterproof, it's fully sealed. The top part, which you saw me where I put the battery in, that has a rubber gasket around it to prevent water from going in. It's not completely waterproof. If you were to put a heavy payload on it and dunk it into a lake and it sinks, it's done. But it can land and take off from water, and it's normally buoyant. And with 2 GoPros, it'll still float. And don't be deceived, the pool noodles on the hexacopter is not for flotation. It will not float in the water. That's just so that when I have it up and flying at a distance, I can still perceive its orientation. So this one uses some DJI components, which DJI is the company that manufactures the Phantom, and they really have come a long way as far as controllability of the aircraft. This is an older one and doesn't use entirely all DJI parts, so it's takes a little bit more coaxing to keep in one spot. As opposed to the hexacopter, which is entirely DJI components. But it's the same principle. If you lose connection, it'll fly back to home, wherever you started it. And
Rick, does that have a built-in camera then that's underneath it?
no, this does not. This does not have a built-in camera. This has a GoPro that you would mount to it with a suction cup mount.
So on top and bottom, you can have 2
yeah,
cameras?
you can suction cup it to the top or the bottom. In this one, really the GoPro is the only camera that you can put on there, or a GoPro type camera, just because it's not as big, it doesn't have the payload capacity. And this one will get you about 20 minutes of flight time. And the newer DJI Phantom quadcopters will get you out to 25 minutes of flight time, or maybe even a little bit more. And they come with an integrated camera on a 3-axis gimbal, so it'll actually compensate for roll, pitch, and yaw movements, so all 3 movements of a quadcopter. And the camera is similar to new GoPros, where it'll do 12 megapixel stills, or it'll actually shoot 4K video now with the DJI Phantom 4. So does anyone have any questions? This one, when we bought it, was about $500. Yeah, a new DJI Phantom 4 will run you about $1,200. Well, I am a video gamer, yes. Born and raised in a video game generation. So yeah, the controls were a piece of cake for me. I've flown these things before getting involved in this here at MTRI. So prior to 2011, I've done a little bit of model aircraft flying. But they've gotten so easy now that anyone could pick it up and fly. But it takes practice to know how to collect good data. With the GPS stabilization, really all you had to do is just, okay, lift it off, let it sit there and hover, and just one movement at a time, and just get used to doing that. The hexacopter is a little bit more complex, just because you have to open up the arms, you have to make sure everything in it is set up properly, you have to make sure all the nuts and bolts are tightened down. A smaller quadcopter like the Phantom 4, they've made it so easy that you can just pull it out of the box and have it up in the air within minutes. You don't even have to tighten anything down. The props on it are self-tightening. So two of them tighten clockwise and the other 2 tighten counterclockwise, because you have each one of your blades are rotating opposite of the other, and that's how it maintains its balance, because otherwise if they're all going in the same direction, it'll just spin due to the spinning nature of the blades. But since they're going opposite, it stabilizes it, and if you want to make movements, it just increases the speed or decreases the speed on certain props to do the movements you want. So it does all the thinking for you.
So Rick, if you blow a motor on that at 400 feet, does that create a problem with the other?
Yeah, it does create a problem with
5 blades that are trying to control it and keep it from spinning?
You won't have complete control of it. It'll be wobbling up there, but you do have some control. Yeah, you do have limited control on where it comes down. It's going to come down. You can't stop that. but you can have some limited control on where it comes down. So you can make last minute adjustments to make sure it doesn't come down on areas that aren't safe for the crew that's out there or bystanders.
Can you show us a demonstration of that, how that might look? And
Yeah, no.
No, I'm kidding.
Yeah, and the only other safety thing is with any of these systems, they're all battery powered, so you have LiPo batteries. So you have to be mindful of storage and charging of these batteries, because if you don't take proper care of them, you can be up in the air and they will all of a sudden just give out. Or they could just all of a sudden have a sudden catastrophic failure and start smoking and getting really hot and could actually damage your equipment.
But some of the new models actually know that it's getting low on battery and it'll just come back, right?
Yeah, both of these have that capability.
They know when it's getting low.
So this has the hexacopter has a built-in feature. You can actually adjust the voltage at which it does an auto return home. So right now we have it set to, if it gets down to 15% battery, no matter what you tell it to do, it'll automatically come back and return to home, just so you don't have a battery failure.